We've learned how to do a lot of things with equations in standard form. Remember, standard form looks like this. There's a number times x plus a number times y equals a number, okay? And sometimes when we're seeing standard form and we're being asked to do things, we're forgetting that we know how to do a lot of different things. We know how to find intercepts. We know how to rearrange it into slope-intercept form. We can solve systems with two equations in standard form, and we can graph it. So let's go over all the things that we've learned about standard form, and then you're going to try some practice problems. But I want you to kind of see all the different ways that we can use this, and then you get to pick and choose which tool you're going to use in a particular situation. So let's talk about finding intercepts. Remember, when we're looking for intercepts, what we're talking about is, here's a graph, right? And if here's the line, the x-intercept, right, this is the x-axis, this is the y-axis, so the x-intercept is this point where the line hits the x-axis, right? The y-intercept, if I just draw, I'm just drawing a random line here, the y-intercept is where this line hits the y-axis right here. So that's what intercepts are. So if I want to find the x-intercept, what I have to remember is that this point right here is going to be a number, right, the x value, but the y value is going to be 0, right? So what I'm going to do is in order to find the x-intercept, I'm going to plug in 0 for y, okay? And my answer is going to look like this. It's going to be a number, and then that 0 that I plugged in for y. So just as an example, if I have an equation like this, and I'm supposed to find the x-intercept, that would look like this. I'm going to plug in 0 for y. Now, 4 times 0 is 0, so this becomes, right, that becomes 0. 3x plus 0 is 0, so that becomes this. I get my x value. Now, the x-intercept is a point, so the x-intercept is x is 3, and what's y? Oh yeah, y is 0. Remember, I made y 0, so this would be the x-intercept, and it's always a point, a number, comma, 0. Now for the y-intercept, remember this point here, like this, for example, would be the x value is 0, right? The x value is 0, it's right here, and the y value is going to be some number along the y-axis. So if I'm going to look for the y-intercept, this time I'm going to plug in 0 for x, right? And my answer is going to have a 0 for x, and then a number for y. So as an example, that might look something like this. Okay, let's say I plug in 0 for x here. That's -2 times 0, that's 0. This is 5y equals -10. Careful here, a really common mistake is like if this is a negative, is just forgetting to bring it down. So just watch for that. In this case, it's positive, so not a concern. This is negative divided by positive is negative, 10 divided by 5 is 2. And again, remember, this is not the answer. The y-intercept is a point. So it's a point where the x is 0 and the y value is the number you just found for y. Okay, so that's finding intercepts. Another strategy we've learned is to rearrange an equation into slope-intercept form. So remember, slope-intercept form looks like this. So you can see that if I want to go from standard form to slope-intercept form, notice slope-intercept form has only the y on the left side. What am I going to have to do? Well, I'm going to first move the term with the x over to the right side, right? So I'm going to move term with x to the right. And how am I going to do that? I'm just going to subtract. I'm going to just subtract this whole term, move it over here. If it's a negative term, I'm going to add it, right? So here, this is going to be adding or subtracting. Okay. Now, the second thing I'm going to do, right, there's going to be a number being multiplied by y, so I'm going to divide to get y by itself. We use the word isolate to isolate y. That means the y is going to be by itself. Okay. So here is an example. Okay, the first thing I'm going to do is I'm going to move the term with the x by adding or subtracting, right? So I would do this. I like to put the line where the equal sign is so I don't lose track of the equal sign. Really common mistake is for the equal sign to end up moving here. I see that a lot. Okay, look, I subtracted this. Don't forget this negative sign. Okay, that negative belongs to that 4. Now here I'm not combining like terms, I'm just bringing down. Okay, and then I'm dividing to get y by itself. Right now, y is being multiplied by -4, so I'm dividing by -4 all the way through. So this gets y equals, right, which is exactly what I want. Now look, this is, watch the signs, this is negative divided by negative. That's positive. Now 3 divided by 4 is a fraction, so I'm just gonna leave it like this. Now you gotta watch for this, because let's say this was an 8 instead of a 3. Then it would be -8 divided by -4. Well, 8 divided by 4 is just 2, so I would just write 2. But in this case, it's a fraction. So I write it as a fraction. 12 divided by -4 is -3. Okay, and there it is. This is slope-intercept form. Okay, now I'm gonna go this way. So remember, we've learned 2 ways to graph this. So option 1 is to do this strategy, okay? To find the 2 intercepts, right? And then just graph the 2 intercepts on the graph and then draw the line. So that's strategy number 1 I can use to graph. Strategy number 2 I can use to graph is this one. I can rearrange it into slope-intercept form, and then I know to graph in slope-intercept form, I start at the y-intercept and then use my slope, my reservoir run. Okay, so just real quick, I'm going to show you the same equation, and I'm just going to do the two different strategies. Okay, so here's an equation. If I want to find the x-intercept, I'm going to plug in 0 for y. That looks like this. I get x equals 5, right, because I divide by 2. So that's this point, where x is 5 and y is 0. And if I want to find the y-intercept, I would plug in 0 for x. Now here, look, this is, remember I said this was a really common mistake, is this, this negative sign, so make sure you bring that down. And when I divide by -5, I get y equals -2. So that's this point, x is 0, y is -2. So look, now I can graph these 2 points, 5, 0, and 0, -2. And I can sketch the line. Looks something like this, okay? So that line is graphed. I can just use this strategy and only this strategy. Or I can use this strategy and only this strategy, okay? And I really want you to see, I don't have to use both. I'm showing you both just so you can see. I can take this and I can rearrange into slope-intercept form. Okay, that looks like this. I would divide by -5. Negative divided by negative is positive. Positive divided by negative is negative. So then this, look, I would start at -2. I would start at a y-intercept of -2. And I would go up to right 5. And notice I would get the same exact line. The last thing that we know how to do with equations in standard form is we can solve them. We can solve systems with 2 equations in standard form. So let's say I have this, let's write this notes first. If I want to solve a system with 2 equations in standard form, I use elimination. That is pretty much always going to be the best strategy to solve when I have 2 equations and they're both in standard form. Now, if I have slope-intercept form, right, that's a different story, but for standard form, elimination is generally the easiest. So let's say I have this system. Let's figure it out. Now, notice, remember, elimination is when I add the 2 and then they eliminate. Here, these won't eliminate, right? What I'm looking for elimination is like +6 and -6, or -4 and +4, or -3 and +3, things like that. So here I observe that there's a 6 right here, and I kind of just, this idea just pops into my head that, oh, 3 can multiply to 6. So this is a 6x. I'm really wishing this was a -6x. That's my wish. So I realized, like, oh, I can make it a -6, right? Because 3 times 2 is 6, and if I want it to be a -6, I'm going to have to multiply it by -2. So I'm going to multiply this whole equation. So -2 times 3x is -6x. -2 times -4 is +8y. And -2 times -19 is, negative times negative is positive, and 2 times 19 is 38. Okay, and then I'm just gonna recopy this one here. And then I'm adding, right? This is -6 plus 6, bam. 8 plus -3, that's the same as 8 minus 3, that's 5y. 38 minus 18, that's the same as 38 minus 18. Sorry, this is 38 plus -18, same as 38 minus 18. I get 20. I'm gonna divide by 5. I get y equals 4. Now what do? Once I have one value, I'm not done. I take this value, I plug it back into either equation, doesn't matter which one. I'm just going to use this bottom equation. Okay, look what I'm doing. I'm plugging it back in for y. Okay, now let's say I had gotten an x value first, then I would have plugged it in for x. Okay, but now I'm just solving for x. 3 times 4 is 12. I'm going to add 12 to both sides. Negative 18 plus 12 is negative 6. I'm going to divide by 6. And I get x equals negative divided by positive is negative. 6 divided by 6 is 1. So my x value is negative 1. So look, here's my, oh, sorry. So here's my, I got x equals negative 1. So here's my answer. X is negative 1 and y is 4. And there it is.